Okay, for this video, I'm going to be doing problems 2 and 3 on page 6. And I'm going to start with problem 3 because it's a little bit easier than problem 2. Okay, so on problem 3, they give us two functions. One of them is 5x squared. The other function is 3 to the x. And I've put both of them into the calculator because I want to check something right afterwards. Okay, first it says that it shows us a graph here. They graphed it for us. Then it says to find the coordinates of the point of intersection of the two curves, here and here. Okay, so let's do that with the calculator. We don't even need to look at the graph because we kind of know what it looks like from here, right? Oh, there it is. It's just like it is here, just like it is here. We're going to do second calc intersect to find the intersection points. So it says first curve, and we'd say yes. Second curve, we say yes. Then it says to guess. And so since there's 2 points of intersection, first I'm going to move closer to the left point of intersection. I'm going to hit enter. And then it's going to give me the intersection point, which is -0.366, comma, 0.669. Okay? And then it gives me a second point. Go second calc. First curve, yes. Second curve, yes. Go a little bit to the right. We can get the right point this time. There's my guess. Enter. Now it's going to give me the second intersection point a little bit to the right. It's going to be 0.633. And the y coordinate is 2.01. Okay, then it says to write down the equation of the horizontal asymptote of the exponential function. The exponential function is this function here, 3 to the x. It's the y2 function. We can find the horizontal asymptote by looking at second table. If we look at second table in the y2 column and we either go up or down, we'll eventually see the horizontal asymptote of the exponential function. Do you see if we go down, or if we go up in terms of the x value, we're getting really big numbers. This is not going to an asymptote. Let's go back the other way. Is this going to an asymptote? Looks like it's getting smaller and smaller. You have to remember that 4.6 e to the negative 4 is 4.6 times 10 to the negative 4, which means 0.00046. Okay, so it's getting very small. As you see, getting very, very small up here. Times 10 to the negative 9th means 0.000. It's like 8 zeros before you get to 77. So y2 is approaching 0. Okay? And that happens to be the horizontal asymptote of the exponential function. Y equals 0. Alright, that's it for number 3. Okay? Let's go now to number 2. Number 2 is similar to all the other problems you've done except for part D. Okay? So let's do everything except for part D, and then at the end we'll go to part D. Alright, so first it says you got two functions, f and g, and eventually they're going to ask you to intersect them. But first they just want you to graph f. Okay, so sketch the graph for f. We'll go into y equals, we'll clear out what's in here, we'll put in the equation for f first, which is 1 plus, and then I'm going to put these in parentheses. 4 divided by x. And if I want to be really, really safe, I'm going to say 4 divided by x, because whenever you have a horizontal line here, it's kind of tricky. You don't see it, but what it implies is that whatever is in the numerator and denominator are in parentheses. Okay? Here it's not going to make any difference, but when you get something a little bit more complicated in the numerator or denominator, that's going to be a problem. Okay, first I've just graphed f, and it says to sketch the graph of f for the values x between -8 and 8. I'm going to use second table to see what those values are. Okay, I'm way off the edge here. Okay, so first of all, I'm going to be at -8, 0.5, so that's about there. Okay? I'm going to go in a little bit, see where I get a nice, oh there, -40, that's a pretty round number. And then I'll go in a little bit more, and then there we go, -2, -1. I got -1 comma -3. And then for 0 I have error. What the heck does that mean? Well, when 0 is error, and what do you know, it says x cannot equal to 0, that means that the asymptote is at x equals 0. It's a vertical line at x equals 0. So I got a vertical asymptote there. So that's part of the graph too. What about at 1? 1 comma 5, that would be here. 2 comma 3, that would be here. 4 comma 2, that would be here. Let's see, let me get to another nice round number. There are no other nice round numbers. The last number is going to be 8 comma 1.5. That's the edge of our graph, right? Okay. Now I'm going to take my highlighter. I'm going to connect. Oh, that's really fat. Oh, let me make it a little skinnier, and then I'm going to connect all these points, okay? Can you tell where the horizontal asymptote is from looking at this graph? It looks like the horizontal asymptote is going to be right there, doesn't it? Because it goes right in between the two graphs. Alright, we're going to check that later. I'm going to draw the x-axis and y-axis in blue. There's the x-axis. Here's the y-axis right on top of the asymptote. Okay, so that's a pretty good graph of our function f. Let's look at what we're supposed to do next. Write down the equations of the horizontal and vertical asymptotes of the function f. Hey, we already did that. Oh, we drew the horizontal and vertical asymptotes, but what are the equations? So one of them is going to be x equals something. The other one's going to be y equals something. Okay, oh, I wrote it reversed. The horizontal one's going to be y equals something. The vertical one's going to be x equals something. So we already know that the vertical one is the opposite of the restriction here. So it's going to be x equals 0 is the asymptote. It's exactly the opposite of the domain. The horizontal asymptote, we looked at this visually, and it looks like it's going to be at y equals 1. We can make sure by going out a ways and seeing that the y value is approaching 1. So we're going to put 1 here because that's the horizontal asymptote. Okay. Now it says to sketch the graph of g on the same axis. What's g? G is a straight line, actually. G of x equals 3 of x. That means a straight line with a slope of 3. Let's say you don't remember how to do that. That's okay. Go into the calculator, program in the calculator the function 3x, and graph it or look at the table. Let's look at the table. The second function is going to be under y2. So we're going to go to y2, and we can see that all the values for y2 are also here, and we can use a few of those points to graph it. Let's use, look at that, it goes through 0, 0, for example. I'm going to graph it in brown. There's 0, 0. What other points does it go through? How about this one, 3, 9? That's a pretty easy point to graph. Okay, what about on the other side? -3, -9. All right. Okay. So there's the graph, kind of like that. Okay. Sketch the graph of g on the same axis. We did that. Okay. Then it asks us, we're going to skip d for now. Write down the range of the function f. Okay. The range of the function f is all possible y values for the function f. Are there any illegal values for the function f on the y direction? Oh, look. There's an asymptote. If there's a horizontal asymptote, that's kind of like saying there's a legal value for y. Okay? So the one illegal value there is y equals 1. So let's put that the range of function is everything except for y is 1. Y is not equal to 1. Okay? And we're done with E. The only thing left is this part. Okay? And this is probably one of the more confusing things that you're going to do in this chapter. Okay? You might look at this and you're saying, what the heck are they asking me? This has nothing to do with the rest of the problem. Well, you got to recognize something. Look at that. Look at that. Look at that. Look at that. Okay? Do you see that they took the two functions and combined them by subtracting them from each other? I'm going to rearrange this a little bit. I'm going to leave 1 plus 4 over x on the left. Then I'm going to take the orange part and I'm going to add it to both sides. And that's going to give me 3x on the right. Now what do I have? Now do you see I have f of x on the left side and I have g of x on the right side? Okay? Now that I have it like this, they say, hence or otherwise, find the solutions of this, f of x equals g of x. So they're saying, when do the functions equal each other? When do the functions equal each other? Well, they equal each other when they intersect. So if we find these two intersection points, then we know the answer to D. So actually, all they're asking us is in another way, where do these two functions intersect? And we know how to do that, especially since we have them both in the calculator. We just do second calc, intersect, and we say first curve. And whenever you get one of these hyperbolas, sometimes you hit enter and it's like, it's not doing anything. But what you do is, the reason why it's not doing anything is because it's on the asymptote. Let's move a little bit to the left or a little bit to the right. Now it'll accept it. Okay, second curve, the line, yes. Guess. Now I can guess two things. I can guess close to this one or I can guess close to this one. Let's find the left one first. So I'm going to move the cursor close to the left one, hit enter, and it tells me that the intersection is -1, -3. So one of the intersections is -1, -3. The other intersection, let's see, we'll do second calc, intersect, it's number 5, and then we'll say first curve, enter, second curve, enter, and the guess, we're going to move closer to this intersection and hit enter. And another intersection is 1.33, 4. So those are the two intersection points for the two functions. Now, one last thing. When they give it to you like this, and it doesn't look exactly like f of x equals g of x anymore, actually they're only asking for the x values. So if you remember to do that, just give them -1 and positive 1.33. You don't need to give them the y's in this case. Okay, that's it.